These are the notes for section 3.1, parallel lines and transversal. The objectives are we'll be able to identify the relationships between two lines or two planes, and I will be able to name angles formed by a pair of lines and a transversal. There's a lot of vocabulary in this section, and basically it's just going to be defining terms and applying the proper vocabulary. First thing we define is parallel lines. They are two lines in the same plane that never intersect. So most of you should be familiar with parallel lines from Algebra 1. They have this symbol, which is an arrow that's shaded in. That's what it looks like on the actual line. We also have this symbol, which are just two lines. This means parallel. So whenever we would read what this says, we would say line AB is parallel to line CD. And like we said here, marking the diagram, arrows, that's these things right here, are used in the diagram to indicate the lines are parallel. Another thing that's important are skew lines. Skew lines are like parallel lines because they never touch. They are two lines that never intersect. The difference between skew lines and parallel lines are that they are not in the same plane. It's kind of difficult to see skew lines on a sheet of paper, but imagine this is a room and we go up to this one corner. So we would say line CF, and then we would have the back top corner, and line AB. These are examples of skew lines. They never touch, and they're not parallel. Another example would be line BC and line GF. Again, just two lines that never touch. So there's a lot of different examples of skew lines. That's just a couple of them. The next thing we have are transversals. A transversal is a line that intersects two or more lines in a plane at different points. So we're going to use this picture to the right to help us see what a transversal is. So it says line R is the transversal. So here's line R in red. So what two lines did line R go through? Well, it went through line N and line M. So that's what we mean whenever we say it intersects lines at different points. So let's erase this and let's take a look at line M. So again, we're going to do line M. This time we'll do it in green. So line M is the transversal. That means it intersects lines R and P. So again, it's the lines that intersect. Transversals will be one of the most important things because we need to define certain types of angles, and we'll continue to do this throughout the unit. It says when a transversal intersects two lines, several special types of angles are formed. So we have line M is the transversal. So there's line M. It intersects line R and line P. So lines R and P. So here's line R and line P. Intersects at two separate points. So what we have here is we have the interior and the exterior. So in between the two intersected lines is the interior. Outside is the exterior. So interior angles are angles on the inside of or between the lines that are intersected by the transversal. So we have 4 angles that are on the interior. That's angle 4, angle 3, angle 5, and angle 6. So I'm going to do this and then I'm going to erase it. This right here is the interior. Do you see how I touched 4, 3, 5, and 6? Those are interior angles. We have alternate interior angles. So these are special types of interior angles. The definition of this is interior angles that are on opposite sides of the transversal. So again, I have my 4 interior angles, 4, 3, 5, and 6. And I want to pick them that are on opposite sides. So if I start with angle 4, I need to go on the opposite side. And I have angle 6. So I have angle 4 and angle 6. There should be something else mentioned. You might think, we're missing something from our definition, but aren't adjacent. Remember, the word adjacent meant next to. So we say they're on opposite sides of the transversal, but they're not adjacent. So if I take angle 3, one that's on the other side is angle 5. So angle 3 and angle 5. Those are my 2 pairs of alternate interior angles. I also have other types of interior angles, consecutive interior angles. The definition here is interior angles that are on the same side of the transversal. So again, we're talking about interior angles. So remember, my interior are these 4 angles here, and being on the same side, that would be angle 4 and angle 5. They're on the same side of the transversal M, so angle 4 and angle 5. I have one more pair of consecutive interior angles. Sometimes these are called same side interior angles. That would be angle 3 and angle 6. All right, so we talked about interior angles. We also want to talk about exterior angles. So if I erase the lines that I've drawn here, I'm still going to keep exterior and interior. We still have the transversal M and lines R and P. So the exterior is on the outside. Remember, if you have exterior paint, that's outside, interior paint's inside. So there's your exterior angles. So where it touches is angle 1, angle 2, angle 8, and angle 7. So exterior angles are just angles on the outside of the lines intersected by the transversal. So again, that was angle 1, angle 2, angle 8, and angle 7. So those are the angles that we circled. We have special properties about exterior angles. The one that's going to be talked about most is alternate exterior angles. So just like with alternate interior angles, this time it's exterior angles that are on the outside, or sorry, on opposite sides of the transversal. So if I take a look at these again, I see I have angle 1, and we might be tempted to say angle 2, but again, just like with our alternate interior angles, but aren't adjacent. Remember, adjacent means next to, so they're not next to each other. So if I have angle 1, I need to go on the other side. That's either going to be 2 or 7. Since 2 is adjacent, that means angle 1 and angle 7 are alternate exterior angles. I also have angle 2 and angle 8, opposite sides of the transversal, both on the exterior. So angle 2 and angle 8. I also have same side exterior angles, which you should be able to guess what the definition of this is. It's exterior angles that are on the same side of the transversal. So this would be like angle 1 and angle 8. And my other example would be angle 2 and angle 7. The last thing I have are corresponding angles. So out of all of these angles, I would say corresponding are probably the most important. So whenever we think about corresponding angles, we need to group the angles into 2 sets. And we need to see which position we are in each of these. So what I've heard a lot of times is if you have pizza and you have 4 different flavors of pizza, the guy in this chair may like something, and whenever the second pizza comes along, he's going to be in the same position. So this is kind of like in the top left. Both of those are in the top left, so an example of a corresponding angle would be angle 1 and angle 5. The official definition of a corresponding angle are angles which occupy the same or corresponding positions along the transversal. So there's my first example. My second example is kind of on top right. That's angle 2 and angle 6. They're in the same position. My third example, whenever I go lower left, angle 4 and angle 8. And the last example of a corresponding angle that I have is angle 3 and angle 7. So again, imagine that you're at a circular table. Angle 1 and angle 5 are in the same position whenever we come there. Angle 2 and angle 6, angle 3 and 7, angle 4 and 8. if you have any questions, make sure to ask me. And I really hope this video was helpful.